MCQ is based on theory of computation. MCQ is based on theory of computation. TOC. First question, unit 1, automata fundamental. Unit 1 is first, automata fundamental. Topic 1, introduction to formal proof. First question, assume that R is a relation on set A. R is a relation on set A. We can write as A relation to B is partially ordered such that A and B are A relation B is partially ordered and A and B are options are reflexive, transitive, symmetric, reflexive, and transitive. Option is D. Option is D. Reflexive and transitive, because a partially ordered relation refers to one which is reflexive, transitive, and antisymmetric. Partially ordered is reflexive, transitive, or antisymmetric. Therefore, answer is option B. Next. Second question. The non-Kleene star operation. The non-Kleene star operation accepts the following string of finite length over set A, curly bracket 0, 1, where string S contains even number of zeros and 1. String S contains even number of zeros and 1. This is non-Kleene star operation. Answer is B, because the cleaning, the star of A denoted by A asterisk is the set of all strings obtained by concatenating 0 or more strings from A. Therefore, answer is B. Set A 0, 1. Therefore, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0. C is not option because here is empty set. B is also not option. And the option is 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1. This is not also an answer because in this option there is odd number of zeros. Therefore, option B is correct. Next. Regular language over an alphabet sigma is one that cannot be obtained from the basic language using the operation. Here option is D, all of the mentioned. A regular language over an alphabet sigma is one that cannot be obtained from the basic language using the operation. Union, concatenation, clean closure, union, intersection, concatenation, clean closure, are all the closure properties of regular language. Closure properties of a regular language. But in this problem, say that cannot be obtained. Therefore, answer is B, all of the. Fourth question. Question. A finite statement 1, a finite automata can be represented graphically. Statement 2, the nodes can be its states. The edges or arcs can be their transitions. In nodes and edges are of trees and forest. Which of the following make the correct combination? Answer is D, all of the mentioned. Statement 1 is false, but statement 2 and 3 are correct. Statement 1 and 2 are correct, while 3 is wrong. None of the mentioned statements are correct. It is possible to represent a finite automation graphically with nodes for states and arcs for transitions. Nodes for states and options are there. Statement 1 is false. This is wrong answer. Statement 1 and 2 is correct and while 3 is wrong. Hence, our option is B, all of the mentioned. Because it is possible to represent finite automation graphically with nodes for states and arcs for transitions. The minimum number of states required to recognize an octal number divided by 3 is option B. Minimum number of states is 3. According to the question, minimum of 3 states are required to recognize an octal number divisible by 3. Which of the following is not a part of finite? 5 is not a part of 5 tuple finite automata. Which of these is not a part of 5 tuple finite automata? Input alphabet, transition function, transition state, output alphabet. Option B is there, output alphabet. A finite automata can be represented as CFA, Q, sigma, delta, Q naught F, where Q is finite state of states, sigma is finite input alphabet, and delta is transition function, Q naught is initial state, and F is final or acceptance states. Hence, in output alphabet is not a part of 5 tuple finite automata. Next, question number 7. If an infinite language is passed to machine learning, the subsidiary which gives a finite solution to the infinite input text is. If an input language is passed to machine learning, the subsidiary which gives a finite solution to the infinite input type is compiler, interpreter, loader, linker, none of the mentioned. Answer is A. A compiler is used to give a finite solution. A compiler is used to give a finite solution to an infinite phenomenon. Example of an infinite phenomenon is language C. Next, the number of elements in the set for the language L, curly bracket, X belongs to sigma R closure, such that length of X is at most 2 and sigma is 0, 1 is. Answer is 7 because sigma R is 1, 0 because length of X is at most 2, hence sigma R is 1, 0, and a clean operation would lead to the following. Set for the language, set count, empty set is there, 0, 1, 0, 0, 1, 1, 0, 1, 1, 0. Therefore, number of elements in the set for language is 7. Option is. Next, for the following change of state in finite automata, which of the following codes is an incorrect option? For the following change of state in finite automata, which of the following codes is an incorrect option? Answer is B. Delta 0, n is equal to n. Delta transition function Q into sigma is equal to Q1 is the correct representation of change of state. Here delta is called the transition function. Answer is B option. Next, 10. Given sigma E comma B, L is equal to X belongs to sigma clean closure. X is a string combination. Sigma 4 represents which among the following? Answer B is there. Sigma clean closure represents any combination of the given set, while sigma x represents the set of combinations with length x, where x belongs to L. X is a string combination and x belongs to sigma clean closure. Therefore, answer is sigma 4 A, empty set A, B. Clean closure combination of given set, any combination. Next topic 2, finite automata. There are data tuples in the finite state machine. How many tuples are in the finite state machine? Answer is B, 5. States, input, symbols, initial state, accepting state, transition function. Transition function maps, option D is there. Inputs are states and input string output is states. Option D. Q into sigma use Q. Option D is there. The number of states required to accept string ends with 10. Answer is A. This is a minimal finite automata. How many states are required to accept the strings with n 10? 3 states. Option. Extended transition function is option A is there. Q star sigma clean closure use Q. This takes single state and string of input to produce a state. Next, fifth, delta star Q Y is equivalent to option B, delta round bracket delta star Q comma Y comma A. First it parts Y string. First it parts Y string. After that it parts A. Therefore, option B. String X is accepted by finite automata if string X is accepted by finite automata if answer is option C. If automata starts with starting state and after finite moves it reaches to final state, then it is called accepted. Hence option C is there. Sigma star Q naught comma X belongs to A. Language of automata is if it is accepted by automata. Language of automata is option A, if it is accepted by automata. Explanation: if a string accepted by automata, it is called language of automata. Language of finite automata is type 3 according to Chomsky classification. Finite automata requires minimum dash number of stacks. Option B, 0. Finite automata does not require any step operation. Hence answer is 0. Number of final state required to accept pi in minimal finite automata. Option is D, none of the mentioned. No final state is required for accept pi and minimum finite automata. Regular expression for all strings starts with AB and ends with BBA. Regular expression. A regular expression for all strings starts with AB and its end with BBA is option C is there. Start with AB and end with BBB. In between, A plus B closure are there. Option is C option. Next. Explanation start with AB, then any number of ARB, then any number of ARB, and ends with BB. How many DFAs exist with two states over input alphabet 0, 1? How many states? D option is there, 64. The number of DFA, how to calculate number of DFA? 2n star n2 star n. Therefore, 64 number of DFAs. The basic limitation of finite automata is that the option, it cannot remember arbitrary large amount of information because there is no memory associated with automata. Next, 14 number of states required to simulate a computer with the memory capable of storing 3 words, each of length 8. Number of states required to simulate a computer with memory capable of storing three words, each of length 8. Option B is there. 3 into each of length 8. 2 into m into n states required. Next question. A PSM with output capability can be used to add two given integer in binary representation. This is true. Use them as flip-flop output. Next, topic 3, deterministic finite automata. Which of the following not an example? Bounded information. Option B, electricity meter reading is not a bounded information. Bounded information refers to one whose output is limited, and it cannot be said that where the recorded outputs are previously until memorized. Language for which no DFA exists is a B, non-regular language. A language for which there is no existence of deterministic finite automata is always non-regular, and methods like pumping lemma can be used to prove the same. A DFA cannot be represented in the following format. Option D, none of the mentioned: transition graph, transition table, C4. A DFA can be represented in the following formats. Which formats? Transition graph, transition table, transition tree, or forest, or any programming language. What the following DFA accept? What the following DFA accept? In this problem, A is the output state, is the output state, and Q0 is the input state. Is the output state and Q0 is the input state. Options are: X is a string such that it ends with 101. X is a string such that it ends with 01. Answer is A. X is a string such that it ends with 101. Strings such as 1101, 101, 1010 are being accepted, while 1001, 1101 are not. This is the conclusion list to option A. In DFA, accept 101. This is a one accepted output state. One is accepted. Next, 0. 0 is also accepted. 0. This is 0. 0 is also accepted, and 0 and 1 is also accepted. Next, when two finite states equivalent, option C, same number of states as well as transition. Option C, same number of states as well as transitions. Two states are said to be equivalent if and only if they have same number of states as well as transitions. Same number of states as well as transitions. Next, what does the figure most correctly represents? Option C, initial state as well as final state with the loop x. Initial state as well as final state with loop x. The figure represents the initial as well as the final state with an iteration of x. Which of the following will not accepted by following DFA? Which of the following will not accepted by DFA? Initial state is given. Dumping state, final state is there. Answer is A. Not A, B, A, B, A, B. B is here. A, B, A, B, A, B, A, A, B. This is not accepted. Option is there. All options B, C, D are accepted. A, B, 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 A, B, B, A, B, B. All three options are accepted, but A option is not accepted. All the strings are getting accepted except A, B, A, B, A, B, A, as it is directed to dumping state. So it is directed to dumping state. A, B, A, B, A, B, A, B, A, because it is directed to the dumping state. But B option is A, B, B, A, B, B, and A, 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 next A, B, 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 A, A, B, 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 B. All three options are accepted, but A option is not accepted. Next, which of the following will the given DFA won't accept it? Q3 is a final state and Q1 is an initial state. Answer is A option. As the initial state is not made an acceptance state, thus empty state will not be accepted by the given DFA. Option is A is there because initial state is not represented. Initial state, this is the initial state, this is not represented, therefore option A is there. As the initial state is not made an accepted state, thus empty state will not be accepted by the given DFA. For the automata to accept empty is an entity, one should make the initial state as also the final state. Can a DFA recognize a palindrome number? Answer is no. Language to accept a palindrome number or string will be non-regular and thus DFA cannot be obtained. Thus, PDA is possible. Push down automata is possible. Which of the following is not an example of final state machine system? Option D. digital switches. Proper and sequential combination events lead the machines to work in hand with includes the elevator, combinational clocks, traffic lights, vending machines, other application of finite machine state systems are communication protocol design, artificial intelligence research, turnstile, etc. Next, topic 4, non-deterministic finite automata. Which of the following options is correct? Statement 1, initial state of NFA is the initial state of DFA. Statement 2, the final state of DFA will be every combination of final state of NFA. The answer is A option. Statement 1 is true and statement 2 is also true, because statement 1 and 2 is always true for given language. Suppose given language is L is equal to AB union ABA clean closure. If X is the minimum number of states for DFA and Y is the number of states to construct the NFA. The initial state of NFA is the initial state of DFA is correct. The final state of DFA will be a combination of final state of NFA. Both options are correct. Next question. Second question. Given language L, AB union ABA clean closure. If X is the minimum number of states for DFA, Y is the number of states to construct the NFA. Mod of X minus Y. Question mark. Answer is A. Construct the DFA NFA individually and obtain the difference of states. Difference is 2. An automation that represents the output based on previous state or current state. Answer is C. Transducer. Output based on previous state or current input. Transducer is an automation that produces an output on the basis of what input has given currently or of previous state. If NFA of 6 states excluding the initial state is converted into DFA, maximum possible number of states for the DFA is option C 1 to 8. The maximum number of states for DFA converted from NFA will be not greater than 2A. Not greater than 2A. Next option is C. NFA in its name has a non-deterministic because of answer is B. The choice of path is non-deterministic. Non-deterministic or deterministic depends upon the definite path defined for the transition from one state to another or undefined multiple paths. Non-deterministic depends on the definite path defined for the transition from one state to another or undefined multiple paths. Next, which of the following is correct proposition? Statement 1, non-determinism is a generalization of determinism. Statement 2, every DFA is automatically an NFA. Answer is B option is correct. DFA is a specific case of NFA. DFA is a specific case of NFA. Given language L, X belongs to A, B, clean closure such that X contains ABA as its subset. Find the difference of transition made in constructing DFA equivalent NFA. Answer is A2. The individual transition graphs can be made and the difference of transitions can be determined. The construction time for DFA from an equivalent NFA, n number of nodes is construction time is B option from the coded NFA DFA conversion O of 2n. If n is the length of input string and m is the number of nodes. The running time of DFA is x that of NFA. Find x. Answer is A option 1 upon m2. Running time of DFA is O of n and running time of NFA is O of m2n. Which of the following options is correct? NFA is the slower to process, which is option C option. NFA is slower to process and its representation uses less memory than DFA. In NFA, while computing strings, take parallel paths, make different copies of input and goes along different paths in order to search for the result. This creates the difference in processing speed of DFA and NFA. Next, topic 5, finite automata with epsilon transitions. According to the given transition, which among the following are the epsilon closures of Q1 for the given NFA? Answer is first delta Q1 comma epsilon Q2 Q3 Q4 Q4 comma 1 Q1 Q1 comma epsilon Q1. Answer is the option Q1 Q2 Q3 Q4. The set of states which can be reached from Q using epsilon transitions is called the epsilon closure over set Q. State true or false. Statement and NFA can be modified to allow transitions without input in tables, along with one or more transitions on input symbols. Answer is true. It is possible to construct an NFA with the epsilon transitions, presence of no input symbol, and that is called NFA with epsilon modes. State true or false. Statement epsilon input does not appear on input tape. Answer is A, true, because epsilon does not appear on input tape. Epsilon transition means a transition without scanning a symbol, that is without knowing the read head. Next, statement 1. Epsilon transition can be called as hidden non-determinism. Statement 2. See, delta Q comma E. P means from Q, it can jump to P with a shift in read head. Which of the following options is correct? C option. Statement 1 is correct and the statement 2 is wrong. The transition with epsilon leads to jump but without any shift in read head. Further, the method can be called one to introduce hidden non-determinism. Next, epsilon closure of Q1 in the given transition graph. Option C. Epsilon closure is defined as set of states being reached to epsilon transitions from starting state. Predict the total number of final states after removing the epsilon move from the given NFA. Option C. The NFA would result after limiting epsilon moves can be shown diagrammatically. That is 3 options. Option C is there. For NFA with sigma with epsilon move, which among the following is correct? A option. Delta is to Q into sigma U epsilon gives P of Q. Due to the presence of epsilon symbol or rather an epsilon move, the input alphabets unite with it to form a set including epsilon. Which among the following is false? Epsilon closure of a subset S of Q is option D, none of the mentioned. All the mentioned are closure properties of epsilon, and in circles all the elements satisfy the following options. Every element of S belongs to Q. For any Q belongs to epsilon S, every element of delta q comma epsilon is in epsilon s. No other element is in epsilon s. The automation which allows the transformation to a new state without consuming in input symbols, option C, NFA1. NFA1 ENFA is an extension of non-deterministic finite automata, which are usually called NFA with epsilon moves or lambda transitions. E transitions are option B unconditional. E transitions are option B unconditional. An epsilon move in a transition from one state to another that does not require any specific condition. The dash of a set of states P of an unit is defined as the set of states reachable from any state in P following the transition. Answer is A, E closure. The E closure of a set of states P of NF is defined as the set of states reachable from any state in P following E transition. Next, the ENFA recognizable language are not closed under the option none of the mention. The language which are recognized by an epsilon non-deterministic automata are closed under the following operations: union, intersection, computation, negation, and star. And clean closure.